So we have a cycle race across America, which is 3,069.25 miles in length. And Juan knows that his average speed for the previous races is 15.12 miles per hour. And for the next race, he's going to cycle for 8 hours per day. Estimate how many days Juan will take to complete the race. Okay, couple of things going on here. This is clearly a distance, speed, time question because we're given a distance and told a speed, and we're asked about a time here. Okay, and so we're going to use our distance, speed, time triangle. Now, quite often people say, those triangles are useless because you don't know where to put the letters. Well, the question always tells you, look, speed is miles per hour. So miles per hour is distance over time. So speed is distance over time. And the question told me that. So the triangle is very useful. Now the other thing that's going on is that we are being asked to estimate. And so we need to think about estimations. And the general rule, and it's a very good rule, is round things to one significant figure. Okay, there are exceptions to that rule, and we might even have one here. So let's say that the length of the race, or the distance, let's call it distance since we're doing a distance, speed, time thing. The distance is 3,069, so that's about 3,000 miles to one significant figure anyway. And then what about his speed? Okay, well, the average speed he gives as 15.12. Now we could round that to 20, but that's really quite a long way from 20. So let's leave it as 15 miles per hour. Okay, now the other important thing to note is he's actually doing it for 8 hours a day. And so what we need to do is we need to multiply that by 8 to get it into miles per day. And 8 15s, well, can we do 8 15s? Let's have a little look down here. If we look at the 15 times table, well, 1 times is 15, 2 times is 30, and to get to 8 quickly now we can just double, and 4 times 15 is 60, and 8 times 15 is therefore 120. So my average speed is 120 miles per day. All right, miles per day. Right, now what about the time? Well, my formula, my triangle here tells me that time is distance over speed. See how easy that is to use? So time is distance over speed, and so we can do that. We're wanting it in days, so that's good. So that's 3,000 over 120. So 3,000 over 120 is, well, let's get the green cancelling pen out, shall we? First thing I can do is knock the zeros off. So it's 300 over 12. Now to aid me in my cancelling, I'm going to write 300 as 3 times 100 and 12 as 3 times 4, because that actually makes the cancelling easier. Now I can see that the 3's cancel, and I also know that 100 over 4 is 25 over 1. And so my estimate for the number of days is 25. Right, Juan, now, sensible fellow, trains for the race. And the average speed he can cycle at increases, and it's now 16.27 miles per hour. How does this affect your answer to part A? Well, the first instinct is that he goes faster, so it takes fewer days. But that's not, be careful, that is not what it's asking. Our answer to part A is an estimate, is it not? We've estimated something. And so the question is, do we estimate 16.27 miles per hour to be different from 15.12 miles per hour? Well, had we seen it as 16.27, we may well have gone to the one significant figure thing, and so we would say 16.27 is approximately 20 miles per hour, so speed increases and the number of days go down. Okay, and so fewer days, if you like, is necessary. Fewer days necessary. Now, it could be that you might have said, well, actually, I'm going to round 16 to 15 anyway, and the answer wouldn't have changed. So be aware that it's an answer to part A they're talking about and not the actual time. Either way, that's good.